So first I'm going to use one example just to illustrate how to run the factorial design. And before I do so, I'm going to give you some conceptual sense of what's happening and how factorial design is different from one-way ANOVA. So I don't know if you still remember this pie chart from one-way ANOVA and this formula. So in one-way ANOVA, we had a pie chart, or we talked about like a certain value is the combination of the mean of the whole total population, the effect of the independent variable, and then random factors that are beyond that independent variable that we are not accounting for. So there's y equals mu plus a or alpha plus error. So that was one-way ANOVA. And for factorial design, or two-way ANOVA, this gets a little bit more complicated. It's still similar, but we have a y, we have a mu, we have the impact of the first IV, but we also have a second IV. So we'll have an impact of the second IV. And then we still have our error. And in addition to that, we have an interaction term of the effects of the in combination of the first IV and the second IV. So that will be an additional component that you'll see in the SPSS output, or you'll be calculating if you were calculating by hand. So there's going to be three different effects. The main effect of A or alpha, main effect of beta, the main effect of the combination interaction of the two. And so if we were doing this sum of squares thing for calculation, the sum of square total would equal the sum of squares of A, sum of squares between group of B, sum of squares between the AB cell, the interactions, and then the sum of squares of the error within group. So in terms of calculation, the A would be the A means minus the grand means. So that will be similar to what we did with the between group for one-way ANOVA. And similarly, B would be the B means minus the grand means. And then for the within group, it would be the scores and how much it deviates from the group mean. And then for the AB interaction, it will be the difference between the AB cell means and the grand mean, the grand mean, and then minusing the SSB. So we're not going to talk about calculation today, but just want to give you that overall concept. So this is how the sum of squares is broken down. There's a between group sum of squares, within group sum of squares. So this is similar to one-way ANOVA. And the main difference here is that between group, it will consist of three components: A, B, and the interaction, and then the within group sum of squares. And this is the formula. This is something you'll have to memorize or know, regardless if we end up teaching the calculation or not, is how do you determine the degrees of freedom. So for the total degrees of freedom, it's the big N, it's the total sample size minus 1. That's similar to one-way ANOVA. And for the between group, it's similar. It's the levels in that group. So if there's 3 groups in the variable A, then it's 3 minus 1, it's 2. And for B, that's the same, B minus 1. And then for the interaction is the sum, is the product of A minus 1 times B minus 1. And then for the within group, it's the total sample size minus number of cells. So that's A times B. So any questions so far? Okay, we'll use the SPSS example, and then we'll try to link that back to these concepts. So this is going to be the example that we use, and I believe I emailed you the data set this morning. So please do download that as you follow with me when I demonstrate how to run the interactions. So the main main variables here, there's three variables. There's two IVs. One is the profession. So what do people do? And then there's three professions. One is administrators, one is belly dancers, and one is politicians. So this is based off of one of the examples in the textbook. And so, yeah, I don't know. I didn't make this up, so I can't give you a rationale of why belly dancers. It's an example of the textbook. Girls, you were wondering, like, why did I come up with what? No. Okay. So, then the other independent variable is vacation length. So it's whether the vacation is 1 week, 2 week, or 3 week. And the outcome variable, dependent variable, is how satisfied are they with the vacation? How much do they enjoy the vacation? And so what's the research question? So the research question is, if, I'm just assuming, hypothetically, if I was a marketing vacation tourism company, and I was planning out tourist vacation packages, and what's the strategic planning of what kind of packages of vacation are we gonna sell? Are we gonna design? Is it gonna be a 1 week cruise, 2 week cruise, 3 week cruise, or how long is the vacation? And then who are we gonna market and promote it to? Like administrators, belly dancers, politicians. We sampled 3 types of people, which we might think have different characteristics to give a sense of what the length of vacation that they would like. So I think this would be very relevant if you were a marketing person. You're planning to promote and design some of the vacation packages. These are 2 different perspectives. So one perspective is the effect of different professions on ratings of a vacation depends on length of stay. So this means like whether there's mean differences across different professions on how much they like the vacation depends on how long they stay. It depends on how the length of the vacation, whether it's 1 week, 2 week, or 3 week. So that's one way of explaining it, or a perspective. And then the other perspective is the effect of different lengths of stay on ratings off a vacation depends on the type of profession. So this is saying that, okay, is 1 week or 2 week or 3 week, what kind of length of vacations do people feel most satisfied? Depends on what type of profession they're in. Okay, so that's another perspective. So I think most of us have liked this chart better, but these are just 2 different perspectives. And in the analysis, they're interchangeable. The results are going to be the same, but just 2 different angles of expressing the findings. But here are some ways of choosing perspectives, or some ways of plotting. Okay, if one of the IV is quantitative and the other is qualitative, so quantitative meaning like number of weeks or how many sessions, the dosage amount. Qualitative, types of people, different treatment. Use the quantitative one as a horizontal axis. So because like horizontal, usually we think like the more right, the higher, I think intuitively. So based on this, it was easier for most of us to understand when we put the length of stay, because that's a quantitative one, as an x-axis. Okay, if one IV is categorical meaning that it's qualitative, use it as separate lines. So pretty much similar to what we're talking about here. So if they're both qualitative or both quantitative, it would be helpful to use the IV that has more levels than the other as the horizontal axis. So if one they have 5 levels, it might be easiest to use that as a horizontal axis. So I would go down this chart. So first see which one's qualitative, which one's quantitative, and decide. And if not, if though you can't determine from those, the more levels as a horizontal. Some could be conflicting though. Some could be a qualitative one has more levels, which we'll deal with in the dental example.